So in this example, we're going to be calculating partial pressures of one of our products when we already have some product present in the reaction vessel. So let's read through the problem. We've been given this equilibrium between carbon monoxide and water and carbon dioxide and hydrogen gas, and the reaction vessel is at 400 degrees C. It says the initial partial pressures are PCO and PH2O at 2 atmospheres, and then the partial pressure of hydrogen is 0.15 atmospheres, and then there's no CO2 present in the reaction vessel. So we want to know what is the partial pressure of hydrogen at equilibrium, and we've been given Kp equals 10 at 400 degrees C. So since the temperature that we've been given Kp at is the same as where the reaction vessel is, we don't have to worry about any changes in temperature. So we won't consider that when we are identifying what's given in the problem. So what's given in the problem is, first of all, we're going to need the reaction to solve this problem. We're also going to need the partial pressures of the reactants and the products. And we're going to need Kp. And the question is, what is the partial pressure of hydrogen at equilibrium? Okay, so I'm going to make a plan here. So my plan would be to set up a Rice table where I write the reaction, the initial partial pressures, the change in those partial pressures, and then the equilibrium partial pressures. And then I use the expressions that I come up with at equilibrium and set those equal to the value for Kp. And then I can solve for the partial pressure of hydrogen. All right, so this is really plan and solve. So I have reaction, initial, change, and equilibrium. So my reaction is carbon monoxide and water, all in gaseous state, is in equilibrium with carbon dioxide and hydrogen gas. All right, so now I can go back to what was given for the initial partial pressures. Carbon monoxide and water are equivalent at 2 atmospheres. And so I'm going to say that these are all pressures in units of atmosphere. I said that there was no carbon dioxide present initially, and that the partial pressure of hydrogen is initially 0.15. All right, so since my stoichiometric coefficients are all 1, the changes are going to be proportional, or the changes will be equivalent. So I would expect that since my Q value, based on the 0 here, my Q value would be 0, that I would be shifting towards the product side, which means that some of my reactants are going to disappear. And again, the stoichiometric coefficients are 1, so the change is going to be the same. And I would expect some products to form. All right, so at equilibrium, I will have whatever the initial partial pressure was, considering the change. So in this case, I would be subtracting x, and over here I'd be adding x. Okay. So now I have expressions for my equilibrium partial pressures that I can set equal to my value for Kp. So up here, I'm going to write Kp which would be the partial pressure of my products over the partial pressure of my reactants. And now I can fill in my expressions here. So I have the partial pressure of CO2 is x. The partial pressure of H2 is 0.15 plus x. Partial pressure of CO and H2O at equilibrium is going to be equivalent, so I can take these two terms and square them. And I can set that all equal to my Kp value, which is 10. All right, so if I rearrange this so that everything is on one side of the equal sign, I'm going to get a quadratic equation that looks like this. And I can solve that using the quadratic formula. That's going to be equal to x. So I'm not going to do that during this video. So you can pause the video now and solve for x. And when you come back, you will find that x is equal to, that you get two solutions. You'll either get 1.50 or 2.96, and you'll have to decide which one is the correct one to use. So if I use 2.96 and I go over here to my reactants and I want to know what the partial pressure of those reactants is at equilibrium, if I subtract 2.96 from 2, I'm going to end up with a negative pressure, and that's impossible. So I know that 1.50 is going to be my change. And that means that the partial pressure of hydrogen is 0.15 plus x. All right. So that's my answer to this one. If I wanted to check it, first, at the beginning, I said that since Q would be equal to 0, that means that it's less than Kp. So my equilibrium should shift towards the products. I can see that I have product being formed here because my equilibrium partial pressure is greater than my initial partial pressure. So this is happening. And then my Kp value is relatively large, so I should have a relatively large amount of products compared to reactants. And I can see that if I subtract 1.5 from 2.0, I'm only going to have 0.5 atmospheres of each of my reactants, while I have 1.65 atmospheres of my, my hydrogen gas product here. So Kp is large, so I should favor products, which is also happening.